Welcome back, Patriots. Let's go ahead and finish up this review. The first thing I want you to notice is don't worry too much about the numbering here. It goes 4, 5, 6, 10, and then over here 7, 8, 9, 10. Let's just roll with it. 10 goes with all of these, and 11 goes with all of these. So we're going to start off by just listing off the congruent parts. So if I can see here that AB has got the 1 mark on it, which is congruent to CD over on the right. I can also see that BC is this middle leg right here, which is going to be congruent to itself. So BC is congruent to BC. Remember, you can always say a side is congruent to itself in any of these congruence patterns that we're looking for. Okay, then we've got AC with 2 marks on it is going to be congruent down over here to BD, also with 2 marks on it. Now for angle A, I can see that angle A is my 1 arc angle, which is going to match over here with angle D. Angle ABC, I'm going to erase all my markings up here. Angle ABC is this 2 mark angle, which matches with my 2 mark angle here, which is going to be angle BCD. Remember, when you have 2 angles that come out of a single vertex, you cannot use a single letter. You have to use 3 letters. And so we started at B, went to C, and then up to D. All right, which means now ACB is going to be, ACB is this 3 mark angle over here, which matches my 3 arc angle over there, which is CBD. Now, write the congruence statement. We're going to do that by writing the first triangle, ABC. Now remember, the order that you write this triangle, the first triangle, does not matter one bit. However, the second triangle matters a great deal. So what we're going to do is take all of our angles and see which one matches, which angle matches. So A is congruent to D, so D is going to go first. Here we've got ABC with B being the vertex, and then so C is the vertex on the is the corresponding vertex on the other triangle. So we're going to put a C there. Now over here, C is in 3rd position. C is my vertex there. So I look at this one and I've got B. Make sure that when you're naming these, the corresponding corresponding angles always line up. Moving on to number 7. Very, very similar here. AB has got 2 marks. My 2 marks over here is CD. BC, the 3 mark angle or side, is going to be congruent to itself. And then AC with 1 mark is congruent to BD with 1 mark. Okay, angle A over here on the side is 1 mark. So does angle D. Angle ACB. ACB is my 3 arc angle. So my 3 arc angle over here is angle CBD. And it's getting cluttered. I'm going to erase those again. Now, angle ACB. Oh, you know what? Those have a mistake on it. I had 2 ACBs. I apologize. Let me go ahead and actually fix that with my whiteout. What that should be instead is angle ABC, which is my 2 mark angle over here. And then I've got my 2 mark angle on the other side. Right here is BCD. Now write the congruent statement, same as before. Triangle ABC is congruent to triangle. A matches with D. B matches with B this time. Wait, I'm sorry. C matches with B. So, hold on. I'm doing this backwards. Or I'm thinking of it backwards. Okay, yeah, C matches with B. And since C is in the 3rd position, B, it's matching when you see go in the 3rd position. Now here we've got B. B matches with C. B in the 2nd position. C goes in the 2nd position. So those ended up being the exact same answer for both of those, but it's not going to happen every single time that way. Make sure you're just following your angles around. Okay, triangle TGS is congruent to triangle KEL. Which angle is in KEL corresponds to angle G? Well, angle G here is my middle position. So the middle position there is angle E. Okay. In this one, which segment corresponds to JL? Well, JL is in position 2 and 3, and then position 2 and 3 there is GS. Remember that these congruent statements are like a roadmap. They tell you exactly what parts are congruent to each other. Okay, write a congruent statement for the triangle here. Well, I see KL, all three of these. It looks like I've got a side, side, side relationship on all three of these. Or I'm sorry, on both triangles. So I got two sides, two sides, two sides. Yep, three sets of sides. So the first triangle, I'm just going to write out K, L, J. And again, that exact order doesn't matter as long as the order is proper over here. Now, K is between the 1 and 3 marked sides. So the thing between the 1 and 3 marked sides here is N. Now, L in the second position is going to be, well, we know these two are vertical angles, so they have to be congruent to each other. So L has got to be congruent to L. We can also see it's between the 1 and 2 marked sides on both triangles. And then my third one, J, is going to have to correspond to M. Now, if I'd asked you and Y, I would just say by side, side, side. Also, whenever I say that the order doesn't matter, I could have also reordered this one and done J, K, L. And that would be fine as long as J still corresponds with M. So J's in the first position, M's the first position. Here, K and N correspond, so K and N, and then the two L's. So either one of those, both of them would be considered right. And by the way, there's actually 6 different ways of writing that. So when we grade your test, we're going to make sure that we look at your individual answers on the free response ones. Okay. Rhombus Qrst is made of 2 congruent isosceles triangles. So it tells us that they are congruent and isosceles. Given that the measure of angle QRS is 46, I'm going to write that in. QRS, this whole angle is 46 degrees. What is the measure of angle Q? Okay, well, I know that isosceles triangles have base angles that are congruent. So I know that this angle will be congruent to this angle. I also know that since the 2 triangles are congruent, that these acute angles over here have also got to be congruent to those, which means in particular that RT is a bisector of QRS. So what that means is that the measure of angle QRT, and let me do that in a different color. So here the measure of angle QRT is going to be half of this, so 46 divided by 2, which is 23 degrees. Now I can write this 23 in here. Since angle T is also equal to it, congruent, it's 43 degrees. And now I can set up this entire equation to find the measure of angle Q. So I've got 23 plus 23 plus the measure of angle Q equals 180 degrees, the sum of the angles inside a triangle. So that gives me 46 plus Q is equal to 180. I'm now going to subtract 46 off of both sides. So Q equals 180 minus 46 is 134. And there we go. I guess I should probably write this properly. At the end, this should be measure of angle Q equals 134 degrees. Okay, number 16. If angle ABC is isosceles with vertex angle B. Now let's go ahead and dissect that. ABC is isosceles with vertex angle B. What that means is B is the vertex, so A and C are the base angles, so those two have to be congruent. Also, the 2 legs, AB and BC, have to be congruent. Okay. AEB is congruent to CFB. So AEB, this, is congruent to CFB, which is this. Which theorem or postulate could be used to prove that triangle ABE is congruent to triangle CBF? Well, also keep in mind here, we're not talking about this middle triangle. That has nothing to do with it. We're only dealing with this triangle and this triangle. So, let's see. If I look at it, I've got 2 angles and a side, but the side is a non-included side. So it looks like this is going to be by angle, angle, side. And remember, this S has to be on the outside, not here in the middle, because the side is not touching both angles. Now let's look over here at this other one. We've got angle, angle, side. Sure enough, they have the same pattern. Therefore, angle, angle, side is the postulate we can use to prove that they are congruent. Okay, now it tells me that segment AB is congruent to segment CB, which is already marked. A is congruent to C, already marked, and BD bisects ABC. Remember, if it bisects, that means that it cuts it exactly in half, so these two are congruent. Which postulate can be used to prove ABD congruent to CBD? Well, again, I've got two angles, and then this side is actually touching both angles. It's the included side, so that's going to be angle, side, angle. And remember, the difference between these two is that on the bottom one, this side length is touching both of the marked angles. The same thing happens over here. Whereas on this guy over here, the marked side only touches angle A. It does not touch angle E. That's why the S is on the outside, and over here why the S is on the inside. Number 18. Okay. If CJW congruent to AGS, CJW is congruent to AGS. Well, if CJW is 45, then over here angle G must also be 45 degrees. Angle A is equal to 50, J is 45. Okay, they're repeating that. What is the value of X? Well, it looks like over here, after I wrote in angle G, I have all three angles, and therefore I can set up an equation. So 45 plus 50 plus 16x plus 5 equals 180. And we're just adding all of those sides together. All those angles together, and that equals 180. So now I'm going to collect like terms of my constants. 45 plus 50 is 95, plus 5 makes 100. So I've got 16x plus 100 equals 180. Now we're going to subtract 100 on both sides. And that's going to give me 16x is equal to 80. And now we're going to divide both sides by 16. And this is going to give me x equals, and I should know that. It's 5. So it's asking us the value of x. So now I am finished. Okay, moving on to number 19. If triangle LMN is isosceles and T is the midpoint of LN. Okay, isosceles tells me, yep, those two sides are congruent. Also, these two angles are congruent, the base angles of the isosceles triangle. And the midpoint of LN means that these two are congruent to each other because T is the midpoint. It means both sides are equal. Which postulate could be used to prove that MLT is congruent to MNT? Well, here I've got two sides marked and an angle, and the angle is the included side because it touches both of the, included angle because it touches both of the sides. Same thing happens over here. Angle N is an included angle. So I've got two sides and an angle, and the angle goes in the middle because it is a included side. All right, number 20. Let's mark in what we got here. XZ congruent to MO, already marked. YZ congruent to NO, already marked. X and M are right angles, already marked. Which theorem or postulate can be used to prove that XYZ is congruent to MNO? Well, in this particular one, you've got a side and an angle, but this angle is the non-included angle, and so that would be technically SSA, which remember we've said SSA does not work. However, we've got the special case. This is a right triangle. So in general use, SSA does not work. However, when we have a right angle, then yes, it can work because the right angle makes things a little bit more special and rigid. However, in that case, we don't call it side, side, side. We call it hypotenuse leg. So that is by the HL theorem. Okay, which postulator theorem can be used to prove that ABD is congruent to, congruent to CBD? Well, as I'm looking at this, I've only got an angle on a side, but I know BD has to be congruent to itself. So in my left-hand triangle, now I've got two sides and an angle, and that's the included angle. So that is going to be side, angle, side. Okay. 22, EG is congruent to IA, is already marked. EGA is congruent to IAG. Now it's important to realize that this extends all the way down. It does not stop at that middle segment. Which theorem can be used to prove that EGA is congruent to IAG? Now this one's a little misleading because the two triangles are proving they're congruent. IAG and EGA are these two triangles. Now, something that I find to be helpful on these is to draw them out separate when they overlap each other. And I'm going to do EGA and then IAG. And now when you do that, also translate in all the markings. So I know EG is congruent to IA. I know that angle G is congruent to angle A. And I also know that because this piece right here, this GA and this GA came from literally the exact same spot, I know that those two have to be congruent to each other as well. Now looking at those two triangles, I can see that I've got two sides and an included angle, two sides and an included angle. That means that this is two sides with an included angle is side, angle, side. Moving on to 23. RST is congruent to XYZ. Find the values of both X and Y. Okay, so I'm looking in this, and I've got angle R marked right here. R is in the first position, and so is X. So I know that angle X and angle R are congruent, which is really convenient because they both have the Y's on them. So I'm going to set up that equation. 4y minus 10 is equal to 3y plus 5. I'm going to subtract 3y on both sides. And that is going to give me, let me scoot this one down a little bit. I promise that says minus 3y. Y minus 10 is equal to 5. Now we're going to add 5 on both sides. And that gives me that y is equal to, I'm sorry. Add 10 on both sides, and that gives me y is equal to 15. Okay, now I'm looking, and I see that I've got RT marked. Well, RT is in positions 1 and 3, which is also congruent to positions 1 and 3, X, Y. So these two are congruent, which again is very convenient because they both have X's in them. So X plus 21 is equal to 2X minus 14. Let's try to collect our X's on both sides. I'm sorry, on one side. And that gives me X minus 14 equals 21. Now let's add 14 to both sides. And 35 is equal to X. Okay, 24. WXY is congruent to WXZ, WXY, WXZ. Okay, find the values, it should just be value of Y. Well, here I can see that I've got XZ. XZ is here in position 2 and 3, which is going to correspond to XY. So these two here are congruent. Now, that means I can set them equal to each other. And let's see. Ooh, I've got 2y plus 10 degrees. This is an angle measure. And down here, this is a side. So I'm going to have to match up the two sides. So 3y plus 7 is equal to 19. Don't take that beta just because it's got a y in it that they have to be equal. So now I'm going to subtract 7 off of both sides. And that's going to give me 3y is equal to 19 minus 7 is 12. Divide by 4. And that's going to give me y is equal to 3. Now, another thing you probably could have done there is we could see that this angle here because this is 90, this one also has to be 90. Therefore, we could have solved it another way. 20y plus 10 is equal to 90. And then 20y subtract 10 is equal to 80. Divide and you get y equals 4. Now that's probably what they mean by the values of y. I don't like that problem. I would not do that to you on the test. Yeah, that won't happen on the test. So I just wanted to put those out there because people probably saw it two different ways. Honestly, that was just a mistake. We should have put an x in there for one of them. Okay, 25. MHJ is congruent to PQJ. Find the value of y. And so when I look at this, there are 2y minus 1 right here. There's no way to know for me to know which side that corresponds to. And so I'm going to have to use just the angle measures. Now, I know that these two are vertical angles, so this is 53 degrees as well. So I'm going to set up my equation. Let me scoot that up a little bit. 14y minus 8 plus 13y plus 53 equals 180. Let's go ahead and combine our like terms here. 14y plus 13y is 27y. 53 and negative 8 make a positive 60. Nope. Sorry, 45 equals 180. Subtract the 45 on both sides. Gives me 27y is equal to 135. And then we're going to divide both sides by 27. Therefore, y is going to equal 5. That looks like a y. Sorry, that's a 7. Okay, 26. Triangle ACB is congruent to triangle CAB. So find the measure of CBA. So this is the angle that I'm looking for. Now, we do have some parallel lines here, which means that I can consider AC a transversal line, which means that this must be congruent to that. Mark this with 2 because I've already got 1 up there. Okay. Whoa. I put that in the wrong spot. Angle DAC is congruent to angle BCA. So what that tells me then is that this over here is going to be 2x plus 8. Oh, you know what? This is also one of those problems we made a mistake on. We should have also said that these two were parallel. And when those two are parallel, that also means that this angle here is 37. And you know what? What am I thinking? All I got to do is use this statement over here. It tells you that angle D is congruent to angle B. So I can go ahead and write my 3x in here. I didn't have to use any of that transversal stuff. I'm sorry, I went the hard way. Okay, so anyway, all three of those angles are going to add up to be 180. So 37 plus, let me do a different color. 37 plus 3x plus 2x plus 8 equals 180. So I don't want those parallel lines things. I'm sorry. They are parallel, but I went the wrong way entirely. Okay, combine like terms. We got our x's and we've got our constants. So 2x plus 3x is 5x. 37 plus 8 is 45 equals 180. Now we're going to subtract 45 on both sides. Gives me 5x is equal to 135. Divide by 5, and that gives me x equals 27. 27. Hey, the answer was 27. That's problem 27. Okay, FHJ goes congruent to HFG. I'm not going to make the same mistake here. Okay, here I've got angle GFH. GFH, position 3, 2, 1. That means that it's going to be congruent to triangle JHF, position 3, 2, 1. So JHF is this one. So these two are congruent. So 6x plus 8 equals 35. We're going to subtract the 8. Gives me 6x is equal to 27. Now we're going to divide both sides by 6, and that's going to give me x equals 4.5. Now, looking at side FJ, FJ is this wraparound position 1 and 3, which means it's going to be congruent to their HG, which again is this one. So 2y minus 3 equals 2.5. Now we're going to add 3 to both sides. 2y is equal to 5.5. So divide by 2 gives me y equals 5.5 divided by 2 is going to be 2.75. Number 28. In the diagram, triangle RST is congruent to triangle ABC. Find the values of x and y. So we've got here RST, so I got angle S, which is in position 2. It's in position 2, has to correspond to angle B. So that means that angle S and angle B are congruent. Let's go ahead and do that problem. 5x plus 20 equals 3x plus 40. You need to get 3x on both sides. And I'm going to do this all in the same step. I'll just write it different. You got minus 20 on both sides. What that's going to do, those two cancel. Those two cancel. And so I've got 2x is equal to 20. Divide by 2, x equals 10. Okay, now I've got ST. ST is my position 2 and 3, corresponds to BC. So yep, these two are, so that gives me 2y minus 8 is equal to y plus 13. Subtract y on both sides, add 8 on both sides, and that's going to give me y is equal to, because those canceled and those canceled, that's going to give me y is equal to 21. Okay. Okay, 29. Name an angle bisector. So we're looking for an angle that cuts a ray that cuts an angle in half. So the segment or ray that I'm seeing that actually does that, it cuts an angle in half, I can see that here this angle is congruent to that angle. So the angle bisector is that ray, which is GL. Now name a median. Remember, a median connects a midpoint to a vertex. So I'm looking at this and I can see that here point J is a midpoint because these two are congruent. So the one that connects that to a vertex is going to be JH. Name an altitude. Remember, an altitude goes from a vertex to the opposite side at a right angle. So when I look at the things that go through the angle or through the vertices, here GL does not meet at a right angle. Here HJ does not meet at a right angle because this right angle here is for over here IJM. But I can see that IK goes from the vertex to the side and does make a right angle. So I've got IK as my altitude. Perpendicular bisector. Remember, bisector has got to cut the side in half, and then perpendicular makes a right angle. We already established that J was my midpoint, and then this is my right angle. So the perpendicular bisector is going to be JM. All right, last two problems. Number 34. Now I can see that these two sides are congruent to each other, so I'm going to go ahead and mark it as 7x plus 2 is equal to 3x plus 10. Now, just like we've done before, we're going to subtract 3x on both sides. I'm also going to subtract 2 on both sides because those will cancel and those will cancel. And that leaves me with 4x is equal to 10 minus 2 is 8. Divide both sides by 4. and so x is equal to 2. All right, last problem, and we're right at 30 minutes in. We're doing good, y'all. We can get this done. Now, on this one, I can see that I have a perpendicular bisector of HN. BK is a bisector because it is a midpoint. We've also got a right angle, means that this right here, KB, is a perpendicular bisector. Now, one of our properties of perpendicular bisectors is that any point on the perpendicular bisector, specifically point K here, is equidistant from the endpoints. So KH has got to be congruent to KN. So my equation is 3x is equal to x plus 10. Let's subtract x. Gives me 2x is equal to 10. Divide both sides by 2. Gives me x equals 5. So that does it for the review. Feel free to reach out. Let me know if you have any questions, and good luck on your test.